good thing to do. The idiom that we used a lot in our file I/O and socket I/O is the untraced buffer wrapper. And you will see this now in Sun's libraries, in the NIO libraries. They have the same thing. You have a traced object that can be handed out, a safe object that can be handed out to safe code, and it can talk to it and interact with it. It wraps a buffer, and the buffer is allocated by malloc. And part of this idiom then is that your buffer you have to free the buffer because otherwise you have a memory leak. So you have to be very careful. You have a synchronized finalizer to free it. You have a synchronized close routine, and depending upon if it's a socket or a file, you're ref counting it or whatnot. And eventually you free the buffer. And you take the untraced buffer out of this, pass it to your native methods. And again, you have types on everything so that the buffer is also type checked. I've explained for you, this is from Spin. So there's, the important thing to remember is that this is a feature that is safe, or would be safe, if only you could extend the bytecodes easily. If you're choosing a set of unsafe extensions, you run into problems. This is inspired somewhat. Doug said, hey, we're going to try and do a JSR for these. Is it JSR? Is that what they call it? A JSR for these guys. I work for Sun, I should know this. So they're trying to do a JSR for these things. They're going to, we'd like to sort of standardize them. And your choice of unsafe extensions says things about how you think you're going to be implementing things underneath. So, the idea that you have safe points, and so you suspend safe point checking in a region, that'll put off the garbage collector. That's really kind of a punt. You don't want to do that. Do you say that you're pinning the memory? Well, your garbage collector might not support memory pinning. So you might really not want to say that. And this is the case where C#'s abstraction is the right one. There's sort of a lexical scoping. You can say, in this area, I have a fixed pointer. And how that pointer gets fixed is, TBD. Maybe you suspend garbage collection, maybe you pin the object. But it's both one object pinned and for a short amount of time. So there is this kind of funny thing where you do have abstraction even though you're talking about something that's unsafe. There's issues of byte order and word size. You would like to have portable ways of doing this. I know that, and plain ways of doing this. I know that Sun's library determines this by taking an integer, doing some loopholing, storing and loading, and says, aha, I must be on a little Indian machine or I must be on a big Indian machine. It should really be a primitive. It should be built in. Whatever the Indianness is, that's what you are. And you should ask it plainly, and it should be statically available. It helps your code run faster. You really don't derive any benefit from learning it dynamically. The next thing that you get when you come to the machine, and this I believe they've gotten right already, is what's under the covers. Is it CAS, load linked, or store conditional, or is it transactional memory? And they're all sort of similar. And even if you implement CAS with load linked, store conditional, or transactional memory, they're sort of similar. So you want your abstraction to be the least common denominator of these things. You get into threading model problems. My examples have all sorts of hooks to let you know about threading related things and essentially thread affinity. And if you were just going to use native threads anyway, you wouldn't think that you needed those. And I've probably not thought of some things that someone else was, you forgot that. So people need to think about these things. If you're compiled, if you're interpreted, I really don't know what the answer is. And I believe this is the last slide. This is a question after the fact, mostly for Java. In Module 3, they had the luxury of defining these extensions ahead of time. And so they had keywords, it all fit, it all worked. For Java, you've got extraordinarily static bytecodes. They don't change. And you've got a relatively static input language, and it also doesn't change. So you're not going to get to add new keywords. You're not going to get to add new bytecodes. So you can't do all of that. This forces some scope changes. whether you could have, in C#, you can actually have an unsafe block. The best you can do in Java is either at the method level, you can encode it with funny names, or at the class level, you can encode it by implementing funny interfaces. And you can do both. You could do it all with dynamic flags instead of with lexical nesting. I think that lexical nesting is the way to go, because the dynamic flag, sooner or later, you forget to reset some mode. You're running your VM in a funny way. That's not a safe thing. I've said this already. You do it with magic names, methods, or types. And you also have to think to yourself, you're encoding both the safe and the unsafe and the boundary code. The boundary code is code that safe code can mention, the unsafe, that can still do unsafe things. An unsafe piece of code cannot be named, cannot be observed by safe code. I haven't talked about security here. I left it out. I should. I should not leave it out. I should talk about it briefly. Do I have time?
Yeah, you have a minute.
I have a minute. Okay. This is something that they did in Module 3. There they had a separation of interface and implementation. And you had three pairs that were interesting. You have safe interface, safe implementation. That is safe code. You could have safe interface, unsafe implementation. This is boundary code. It can be mentioned by the safe code because it has a safe interface, but it may also do unsafe things, and it may mention and access unsafe code. And the truly unsafe stuff has both an unsafe interface and an unsafe implementation. In a world like Java, and especially with 3 guys trying to get something done in a hurry, you make quick rules, and the quick rule here was we're never ever going to dynamically load anything but safe code. And the existence of unsafe code will always be hidden from the safe code, period. It's a simple rule. It avoids all sorts of nasty problems. And you don't get spurious exceptions. You just can't see it. You can't name it. And it's in sort of a nice orthogonal security rule, independent of the Java namespace rules, that you can also add, and it's easy. And it's an old solution, so it's tested. And that is my talk. I hope it was quick enough.
Before people ask questions right now, if you are interested in participating, this will probably be proposed to JCP within about a month. As I said yesterday, it's one of those things that it's got to be done before this gets out of hand, and it can be done very conservatively, or it can be done with the same spirit David just had. And that could be the fun part of this JSR.
Okay. I don't know if I want to participate.
So can you comment on your thoughts about the CLR and how it handled it?
They failed in 2 ways.
Okay.
The first one is they did it with blocks. They made it, I think, too easy. I think you really want a barrier to entry to write unsafe code. We used ugly method names, and we were completely unashamed of that. We figured it was a feature, not a bug. The other reason that I think it's a problem is that you rely on punning. Well, you see, you don't really care because you own the OS too. But so maybe this isn't a problem for Microsoft. But you rely on punning to get the data layout right, to go from the safe to the unsafe. It's the same type as it ever was. You just fixed it in memory for a little while. And so the data layout had better be what is expected. Again, that is, for Microsoft, that's not a concern. I mean, mainly when I first looked at the C# design, my snap reaction was, God, these guys don't trust their compilers. They don't believe they're going to do any inlining. And you got to do inlining.
So by my watch, you have 1 hour and 2 minutes to sleep. I take advantage of that.